All right, so moving on, we're almost getting toward the end of the chapter. So 6.6, I think this is an easier one, hopefully you agree, is on what's called geometric sequences. And we've talked about arithmetic sequences before. We've actually kind of talked about this just in a different terminology. Earlier in the chapter, we did some questions that were on, is this linear or exponential? And today it's just different terminology, but it's talking about the same thing. So I'll show you what I mean in just a second. So the first thing we're going to have to do is common difference. You might remember that back in, I think it was chapter 4. But if we started how do we get from one number to the next? You know what, let me back up. Geometric sequences are multiplying and dividing. So when it says here, find the common difference, we don't want to look at, okay, plus 4. We don't want to look at adding and subtracting. Okay, times 2, times 2, times 2. So the common difference is times 2. Okay, it could have erase that. So, obviously it's going down, so it's got to be divide. And maybe you look at 125 to 25 and you're like, I don't know that. That's okay. Don't look at that first one. Just go from 25 to 5 and say, okay, well, that's divide by 5, and then 5 to 1, that's divide by 5. And chances are pretty good then that'll be divide by 5 also, which it actually is. So if you look at like the beginning part of ones that are going down and the numbers are just kind of big and you're not like comfortable with them, that's fine. Go to the next ones and you'll probably be able to figure it out from there. So the common difference is just divide by 5. Or the book might put it, let me see, yeah. They put it as times 1/5. Or just the common difference is 1/5, which means divide. Fractions mean divide. This means divide by 5. So if you get one that's going down and you say, hey, that's divide by 3, put 1/3. Oh, that's divide by 4, 1/4, and so on. Okay? All right, so common difference. Then you'll do some problems where it's going to ask you, is the sequence arithmetic, geometric, or neither? Okay, so arithmetic would be adding or subtracting, and geometric would be multiplying or dividing. And so I'm going to put the word same here. It's like the same number, plus 3, plus 3, plus 3, times 4, times 4, times 4. And there might be a pattern to what's happening, but if it's not the same number, then the answer is neither. Okay, so you're just going to look at a sequence of numbers and say, okay, well, And here's the thing you could look at too, like it goes from 12 to 21. Like that's over 4 numbers that only went up a little bit. So it's probably arithmetic or neither. And so when we look at this one, we say, okay, well, that's plus 3, plus 3, plus 3. So then this one is arithmetic. Okay. Okay, so look at how much this goes from 2 to 128. It goes up a lot. So that's going to be a clue that it could be geometric. So this is times 4, times 4, times 4. Okay, so geometric. And then if it's going to be neither, it's just, again, you might be able to find a pattern, but if it's not consistent, so if you look at this one, again, it doesn't go up that much, so it's got to be adding plus 2, then plus 3, then plus 4, then plus 5. Okay, well, it's addition, and there's a pattern, but I don't care about a pattern. It needs to be the same number for it to be arithmetic or geometric. Okay. All right. Then you're going to look at a couple graphs and answer the same question. Determine whether the graph represents an arithmetic sequence, a geometric sequence, or neither. And there's some points on a graph, and the coordinates are listed on the graph. One of them, or it could look something like this. I don't know if I have enough room to get all the way. Yeah, it goes all the way to like 19. So it has like 1, 4, and then it has 2, 11, and then up here somewhere it has 3, 16, and then it has 4, 19. Okay, and on all your problems, you're going to have 1, 2, 3, 4, like for the x's. So really, what you want to do is I'm going to rewrite just the y numbers, 4, 11, 16, and 19. And then I'm going to do the problem just like I did right up here. Okay, so it doesn't go up that much, so it's got to be adding. So that's plus 7, that's plus 5, that's plus 3. So this is neither, because there's not a common difference. It's not the same number each time. Okay, so you'll have two problems that are graphs. Just write down the y numbers and then determine if they have a common difference that's multiplying or dividing, adding and subtracting, or again, it could be neither. Okay, and then you're going to have just the last three problems are going to be just write the next three numbers in the geometric sequence. It says then graph, you don't need to graph. Okay. So here's kind of a different one. Okay, so first I notice I'm going to ignore the fact that we have negatives and positives, and I'll come back to that. So from 3, and in the directions it says geometric sequence, so it's kind of telling you it's going to be multiply or it's going to be divide. So this is times 4, and that's times 4, because 3 times 4 is 12, and 12 times 4 is 48. It's got to be times 4. I wouldn't expect you to know what's 48 times 4 just off the top of your head, but if the other two are times 4, that's what it's got to be. Now, it goes negative, positive, negative, positive. That means it's really negative 4. Okay, so you got to do, and again, I got to do 192 times 4. Yeah, use a calculator. I wouldn't expect you to, you can, I'm letting you use a calculator on a bunch of other stuff this chapter, so why not here? 192 times 4 is, so it said the next 3 numbers. So I'm going to get negative 768 times negative 4 again. I'm going to get positive 3072 times 4 again, or negative 4. And I'm going to get negative 12,288. So you could get some big ones, because when stuff is exponential and it's multiplying, times 4, or times anything for that matter, 2 maybe it goes up a little bit slower, but it gets big pretty fast. Okay, so just what are the next 3 numbers? And so remember, if it says, if you look at it and go, oh, that's divide, then, so like, let's look at this one. Whoops. Okay, so what are the next 3? Well, 375 and 75 is kind of big. Maybe even 75 and 15 is kind of big. But, so 15 and 3, how do I get from 15 to 3? Well, that's divide by 5. So then maybe you get your calculator out and test, 75 divided by 5. Yeah, that's 15. Okay, so this is divide by 5. And so the way that the book really does it is times 1/5. Which actually I think is easier, because then what's 3 divided by 5? Well, you can't do that. But I can do 3 over 1 times 1/5 and get 3/5. And then I can do 3/5 times 1/5 and get 3 over 25. And then I can do 3 over 25 times 1/5 and get 3 over 125. So if you notice, 3, 3, 3. Okay, that'll happen each time when you get to a fraction, where that top number will end up staying the same, and then you're really just multiplying the bottom number. Okay, so I think there's one like that. Okay. All right, so hopefully not too bad. You're just doing odd problems. I think it's 11. 3, 6, 9, 10. Yeah, 11 problems. So it's not a whole lot. Okay. All right. Have a great rest of your day. See you tomorrow.